From the very beginning, man has struggled ever onward in his conquest of time and space. For countless centuries, lofty mountains mutely challenged him, standing as stalwart barriers across his path. Upon the oceans that surrounded him, he launched his ships. At the mercy of wind and tide, they made slow headway across the waters. Over the lowlands, the wilderness of desert and green valleys, he plodded his weary way, earthbound in the conquest of time and space. But man is no longer earthbound, and Lockheed rides the airways with a thrust of bright propellers and the flash of gleaming wings. And behind this Lockheed lies aviation history. In 1903, on the plains of Kitty Hawk, North Carolina, this history began. In the granddaddy of all modern planes, the Wright brothers won immortality by sustaining flight in a heavier-than-air flying machine. There is no fuss or ceremony, no cheering crowds. The motors flutter and catch, weights drop, the ship catapults off the ground into the air for the first flight on record. Since then, aviation history is written in a never-fading book of records. In 1928, a Lockheed Vega, the well-known Yankee Doodle, reaches New York from Los Angeles in 18 hours and 58 minutes. At the controls are Colonel Arthur Goebel and Harry Tucker. In 1929, Captain Frank Hawks climbs aboard his Lockheed to set a new transcontinental mark. Good luck, Captain. New York is only 3,000 miles away. Off on his way to a new record, one of the many he is to establish in the years that follow. Into the cockpit of his Lockheed Sirius climbs Colonel Charles Lindbergh. Mrs. Lindbergh is with him. Flying together, as always, they are heading from Washington, D.C., across the Bering Sea to Japan. A perfect landing after almost half the world has rolled by beneath their wings. Cheers and waving flags as Tokyo greets them. That same year, 1931, Ruth Nichols lands her Lockheed Vega after establishing a new feminine altitude record of 28,743 feet. Nice going, Miss Nichols. 1933, a famous Lockheed, the Winnie Mae, carrying a famous flyer, comes home from a solo flight around the world. What an achievement for Wiley Post. First man to fly around the world alone, and first to fly around the world twice, both times in a Lockheed. Colonel and Mrs. Lindbergh are starting on another and perhaps their greatest journey. A 29,000-mile survey flight from New York to Labrador, Greenland, Iceland, Europe, the Azores, Africa, Brazil, and return to New York. 1934 finds Sir Charles Kingsford Smith, together with Captain P.G. Taylor, completing a 7,000-mile trip from Australia to Oakland, California. It is the first crossing of the Pacific from west to east, and Sir Charles, in his Lockheed Altair, the Lady Southern Cross, has made it in less than 55 hours. This great flyer and great plane certainly deserve congratulations. In 1935, Amelia Earhart flies her Lockheed from Honolulu to Oakland. She is the first woman to make a solo flight over the Pacific, covering the distance in 18 hours, 16 minutes. The crowd hails her for an outstanding performance. 1938, Howard Hughes hurries to his plane for the start of his race around the world. 3 days, 19 hours, and 9 minutes later, his Lockheed brings him back to New York and a new record. In less than 4 days, he saw 5 sunrises, and the plane actually beat the revolution of the Earth on its axis. Records and more records. And these are just part of a long list. But exciting as they are, they mean nothing to the true goal of aviation unless the experience gained is applied to further the speed, safety, and all-round performance of air transportation. And with the cooperation of the pilots who made these famous flights, Lockheed has been able to achieve that performance and create new standards of efficiency. That was true in the development of this Electra, which was Lockheed's first all-metal bimotor transport. It made history on the air lanes of the world, and every subsequent model has lived up to its tradition. Here is the 12. It is a smaller ship, accommodating 6 passengers and answering the proven need for a plane that can combine economy with the performance of a large airliner. This Lodestar is a luxury transport. Certainly one of the best looking, it is today probably the fastest commercial ship on regular airline service. And for the convenience of all customers, service and parts depots have been established throughout the world to maintain the peak performance of Lockheed's vast fleet. And in all corners of the globe, 24 hours of every day, these ships fly the airways in routine flight, confidently accomplishing the jobs for which they were built. The conquerors of time and space. Lockheed over North America. United Airlines, Continental Airlines Incorporated, Mid-Continent Airlines Incorporated, Northwest Airlines, Chicago and Southern Airlines, Braniff Airways Incorporated, National Airlines, Delta Airlines, Boston Maine Airways Incorporated, Trans-Canada Airlines, Pacific Alaska Airways. Lockheed over Central America, Líneas Aéreas Mineras, TACA, Cia Nacional Cubana de Aviación. Lockheed over South America, Pan American Airways Incorporated, KLM, Air France, Avianca, Línea Aeropostal Venezolana. Lockheed over Africa, Air France, Air Afrique, Aéreo Maritime, South African Airways, DETA. Lockheed over Europe, British Airways Limited, Aer Lingus Terranta, KLM, LOT, Aeroput, LARES, Romania, Air France. Lockheed over Asia, KLM, KNILM, Japan Air Transport Company Limited. Lockheed over the Antipodes, KNILM, McRobertson Miller Aviation Company, Guinea Airways, Ansett Airways Limited, WR Carpenter Airlines, Union Airways of New Zealand. Lockheed's also served high government officials of the Netherlands East Indies, Mexico, Venezuela, Brazil, Argentina, Australia, Canada, Great Britain, India, and the United States. Worldwide coverage, but it has not been accomplished in a day. It is the result of a smooth-running combination of men and machines. In that combination lies the story of Lockheed itself. It is a success story, modern, exciting, typically American. The Lockheed Aircraft Corporation plant, Burbank, California, in 1926. And today, the same company, the same location, but quite definitely not the same plant. As recently as 1932, sales aggregated the overwhelming total of $23,298.03. In 1940, actual deliveries amounted to more than $42 million, and conservative estimates indicate that in 1941, this figure will be more than doubled. And to the men of Lockheed belongs a large share of the credit, to their skill and to their loyalty. They are a cross-section of typical American workmen, drillers, riveters, toolmakers, die-casters, machinists, and technicians. In 1931, there were only 300 of them. 1941, over 35,000. Every man who checks in, from office boy on up, has taken and passed exhaustive tests covering intelligence, temperament, and special aptitude to prove his individual ability. 35,000 American workmen, the right men for the right jobs to build the best planes. This is not a trick shot made with mirrors. It is the drafting room of the engineering department where every new Lockheed has its beginning. A beginning conceived with the purpose of supplying the answer to definite needs of the aviation industry. To attain this goal, over 850 engineers make over 5,000 drawing plans, devoting a total of over 200,000 work hours to their mission of creating one new design. The component parts of a modern airplane's wing, fuselage, and tail surface are almost countless in number, yet every single one of them must be engineered. Even the most minute part receives the greatest attention. 4 separate drawings are made showing detail from 4 different angles. Although the part is no larger than a silver dollar, it will have to go a great deal further. The interior of a plane is one feature of design seldom associated in one's mind as coming under the supervision of the engineer. Yet one of his most important jobs is to provide utter comfort for passengers traveling through the air at high speeds. The Lodestar's cabin has been designed for this comfort. Inside, the sound of powerful motors is reduced to a pleasant hum by scientific soundproofing and vibration control. Restful chairs, ample space, and headroom are results of thoughtful planning, and all Lockheeds are especially adaptable to the requirements of private owners. For businessmen to whom time means money, the Lodestar is convertible into a convenient and dependable office in the sky. The compact 12 becomes a comfortable lounge for attending important events anywhere at any time. The cabin of Lockheed's new four-motor transport, the Excalibur, will look very much like this. Although the plane is still under construction, the engineers have built an exact replica, known as a mock-up, out of wood. In this way, every possible detail of passenger comfort can be effectively predetermined and applied. But the ideas and plans that this man and the hundreds like him put into execution are not only those of Lockheed's chief engineers, but those of the entire flying world. For the Market Research Division maintains close contact with the operative branch of the industry. The staff compiles lists of important features relating to a plane's design. These findings are set up in the form of questionnaires. If you were to build your own ship, on the flight station, where would you locate emergency controls? On the engine control stand, where would you put the levers? And the rudder pedals? These comprehensive questionnaires are sent to airline executives, pilots, transport officials in every corner of the world. To Trans-Canada Airlines, R.C. McLeod in South Africa, Tri-American Aviation, Buenos Aires. The list is almost endless, but to mention a few more, American Airlines, Lieutenant Thatch, VP-5 Squadron Canal Zone, and British Airways. The replies to these pamphlets are carefully sorted, for they represent knowledge gained under actual flight conditions. Detailed graphs and charts are compiled by competent statisticians. No suggestion is too small. Every answer to every question is checked and noted. These findings are recorded in another pamphlet. You told us this is the way you would do it. On flight station, on engine control stand. And on rudder pedals, we asked, are brake toe pedals desirable? 93% said yes, 7% no. That verdict is submitted by men whose combined opinions represent the experience of over 16 million hours of flying. These practical viewpoints, as gathered by market research, are submitted to the engineers. They combine these ideas together with their own creative ability in the conception and building of every new Lockheed plane. That's how Lockheed designs airplanes to suit the men who know airplanes best, operators, pilots, and regular airline passengers. And the first form a new plane takes is on paper. From these drawings and thousands like them, an exact scale model known as a wind tunnel model is made and is connected to instruments which determine its flight characteristics. The model is hand-carved, accurate to the fraction of an inch, weighs over 500 pounds, and costs more than $5,000 to build. The door is closed, the wind tunnel sealed. A flip of a switch, and the wind propeller whips up to speed. The model is exposed to a far higher velocity than this 90-mile-an-hour wind. The small wind tunnel model is actually subjected to and withstands a much greater force. From an idea to an actuality, from theory to fact, from a model to a completed Lockheed, the plane has been built. More than that, into it has been built the strength, ruggedness, and durability necessary for its safety and high-speed performance. But not so long ago, this shining plane was only a small part of a trainload of metal addressed to Lockheed. For the metal inside these wooden frames is the stuff that planes are made of. Hard and strong, it must be fabricated by men and machines into the parts that make airliners. Giant shears act as huge mechanical scissors. Metal sheets are slipped into place. The sharp blade strikes and cuts through them as if they were cloth. The high-frequency router, a dental patient's nightmare, turns 15,000 revolutions a minute and cuts layers of metal into their first rough shape. The bit turns so fast that it must be cooled by a constant stream of oil. The massive hydro press exerts an overall pressure of 9 million pounds, and it literally squeezes parts out of metal. An endless chain of roller conveyors carries a tray with the forms to workmen. They put the metal which has already been cut to the correct size in place on the forms. The tray now continues on its way into position under the press. The operator touches a switch, the press starts down, and look out below. Almost unbelievable pressure, an irresistible force, but under perfect control. And where plain sheet metal went in, finished parts come out. The hydro press turns out more parts in 1 minute than 2 men could complete in a whole day, and turns them out better and more accurately. A compressed air stamp which forges metal is an excellent example of powerful machinery under absolute control. Taps as gentle as a tack hammer, then the crushing impact. What a nutcracker this outfit would make. And yet its control is so delicate that it can crack an egg, at least so the operator claims. Look out there, a little too hard and you'll have an awful mess. Be careful. Well, hello, stranger. You certainly have a brand new kind of a mama. Skilled men and precision machines have fabricated these parts. But even metal can be strengthened and protected. To do this, there are several types of processing. Complete electrochemical anodizing baths provide parts with a protective coating of oxide film. This is a safeguard against the threat of corrosion caused by moisture. It is an interesting fact that these parts are protected against any harmful effects of moisture by being given a bath. Another type of bath is used for a different purpose. In order to harden and thereby strengthen certain parts, they are immersed in a hot salt solution of sodium potassium nitrate. In large ovens, other parts are hardened by baking at 1550 degrees Fahrenheit and quenching them in oil. It is easy enough to say that these parts, which will eventually be the plane, are strong. To prove that they are, to constantly guard the Lockheed measure of strength is the duty of the testing laboratory. A spectrograph is one of the most modern scientific testing devices. It analyzes the purity of the metal alloys which go into a plane. Tremendous heat created by an arc burns sample filings of the metal. These filings are placed in a cavity on the lower of 2 acid-treated graphite electrodes and then burned. The light of the burning metal passes through a lens and then through a rotating sector, the adjustable opening of which controls the amount of light falling on the slit. The light now passes through the slit and falls upon a diffraction grating. This diffraction grating is a concave aluminumized glass plate on which 24,000 lines per inch have been ruled with a diamond point. The light is separated by the grating into wavelengths. These wavelengths, or light rays, fall upon a strip of film, and a photographic record of them is thus produced. Since each element has its own wavelength, from the developed film it is possible to determine exactly which are present in the alloy. In this manner, the spectrograph immediately detects all impurities, and any inferior metal is promptly discarded. The sole purpose of this huge machine is to break things. Its powerful jaws, capable of a compression of 300,000 pounds, are about to crush a small section of the wing in order to measure its resistance. Now watch carefully. The upper jaw is clamping down with an invisible, relentless force on the seemingly frail strip of metal. But actually, just how frail is it? 60,000 pounds? 70,000? There it is, a slight ripple. The breaking point has been reached, and it takes a pressure of over 80,000 pounds to even bend this frail little section of a wing. For contrast, let's see what happens to a solid cylinder of concrete, which certainly appears much stronger. There's the first crack, and the concrete shatters completely under a pressure of less than 75,000 pounds. All stressed parts, such as forgings and castings, are X-rayed for any possible flaws in the metal. Lockheed X-rays more parts than all other aircraft manufacturers combined. They may look new and shiny on the surface, but that doesn't matter. What are they like underneath? This batch is fine, perfect. A different story here. Those slight, almost imperceptible flaws which doom it to the scrap heap would be invisible to any eye other than the X-ray. Therefore, although it is important to know what is on the outside of a plane, every stressed part is X-rayed because Lockheed thinks it is even more important to be absolutely positive of what is on the inside. Yes, every part of this plane is built for the strength, ruggedness, and durability to achieve the highest speeds. And there goes the Lodestar. Carrying a full load of 17,500 pounds, it speeds down the runway for the takeoff. In 15 seconds, after a run of only 860 feet, it leaves the ground and soars into the air, climbing rate 1,200 feet per minute. And while the plane is in flight, the dials and indicators on the panel are the guides by which a pilot flies. Over a half a mile of wire connects them with the controlling instruments, which must be infinitely accurate before they are installed. In the instrument testing laboratory, each instrument and accessory is, to all intents and purposes, actually flown before being installed on the plane itself. For instance, on this stand, a motor duplicates the swing of a plane to test the turn and bank indicators. Here, tachometers are also tested, and propeller governors, vacuum pumps, fuel pumps, starters, generators, and hydromatic motors for feathering propellers. The automatic pilot is checked by a vacuum system against mercury manometers. This small box can guide a plane in flight, keep it as true to its course as the most experienced pilot. An airplane is a chain of which the thousands of separate parts are the links. They must be forged together in order to shape the wing, the tail, and the fuselage. The duty of the wing is to provide the lift that sustains the flight of an airplane. Here in the plant, it must be assembled as flawlessly as it was designed. Although a wing is generally considered as a unit, it is really composed of 3 parts, 2 outer sections and the center section. We are all familiar with the general shape of a wing, but while an outer section is in the first stages of assembly, we can get a good idea of the complex structure on the inside. Every rib and crosspiece has its purpose. Remember, it was just a small part of the wing that we saw withstand a compression of 80,000 pounds. Each operation is executed with precision and care as the outer section moves down the production line and takes shape. High-speed electric drills punch holes for the rivets. There are more than 700 drillers or riveters who have all had previous training. Even so, before they're assigned to actual production, they must attend Lockheed's own school until they can uphold the plant's standard of efficiency and skill. There are more than 50,000 rivets on a completed wing, and every one of them is checked, examined, and checked again. This requires an army of over 200 inspectors, such as this one. But by the time a Lockheed plane is assembled, every square inch of it has been inspected at least 5 times. Inspector number 158 finds this row perfect and okays it. And the story of one outer wing section is the story of 10, of 20, of 1,000 sections as they move down the line in an endless parade. Mass production with the emphasis on precision and quality. The assembly line for the center section of the wing is one of the largest and most vital units in the plant. It has to be because the center section is the strong man of the plane. It must be constructed and assembled so as to be able to support heavy loads and to withstand great strain, for it unites the 2 outer wings with the fuselage. The fuselage will eventually rest in the gap between the 2 shoulders, and the wings will be joined like arms on either side. The main beam of the center section is the strongest part, the backbone of the entire plane. Like a bridge, it must carry any burden with steadfast dependability. And the main beam is built just like a bridge. At all times, it carries all of the flying load, the engine load, and the landing load. And it is stressed to support more than 5 times the total weight of the fully loaded plane. Completed and assembled, capable of supporting a static load of 70,000 pounds, the wing will do its job as the men who built it have done theirs. The tail surfaces control the maneuverability of a plane. The use of twin rudders was developed by Lockheed and are one of the distinguishing features which point out every Lockheed. The fuselage is the body of the plane. It represents the final word in aerodynamic design and streamlining. And during construction, these basic principles are built into the fuselage and applied to every operation from the beginning to the completed shell. As the first step in its assembly, the bulkheads are joined together by stringers, which form the basic shape and strength of the fuselage. Skin fitters then fit and shape the metal sheets, attaching them with removable fasteners. On their heels come the riveters, while every stage of the assembly is constantly under the close check of inspectors. Assembling with electric continuous spot welders facilitates production and gives many fuselage parts an extra smoothness for better streamlining. With an eye to the future, Lockheed is constantly enlarging on this process because better streamlining means greater speed. And so another fuselage is finished and ready for mating with the wing. Like a ship being launched, it moves slowly down the ways. Slowly now, yes, but for just a little while longer. Soon sunlight will be glinting from its metal sides. Its nose will point upwind. In the comfort of its cabin, passengers will read or write or sleep or think after their own fashion, and beneath it, the lakes, rivers, and valleys of the countryside will unfold. Slowly still, the fuselage is lowered into place, united with the wing, and now, slow no longer. Speed on the water. Speed on the snow. Speed on wheels. On rails. Speed on wings. There is truth in the slogan that it takes a Lockheed to beat a Lockheed. And as the plane approaches the field, it slows down for the landing. The Fowler flap has been adopted and developed by Lockheed. The flap gives a greater lift to the wing and provides a brake action to reduce the speed. The plane lands at 65 miles an hour, and from a height of 50 feet, it can come to a complete stop in less than 600 yards. This Lockheed Lodestar, with its safety, its comfort, and its great speed, typifies the ideals of aviation in America. To protect these ideals, Lockheed is contributing its share toward national defense and the defense of democracy in other parts of the world. These B-14 bombers, better known as the Lockheed Hudson bombers, are rolling off the production line at an ever-increasing rate. They have been ordered in great quantities by Great Britain and Australia. When ready for delivery by boat, the Hudson bombers are dismantled. The sleek fuselages are carefully encased in canvas, and the wings, already stowed away below deck, are crated in wooden frames for safe shipment. When the planes reach their destination, they are easily reassembled and soon ready to take their places in the staunch defense of the British Empire. And while these planes start on their long journey by water, others are being given their final test flights for the tough job ahead. And still more are winging their way directly toward Canada. In combat, in actual line of duty, the Hudson bombers have won a name for their efficiency and dependability. And as America builds its planes for commerce and for defense, it is well to remember that Americans invented the airplane and developed the modern conception of mass production used by Lockheed. And out of the vast production line come Lockheed's, the 212, the Electra, the 12, the Hudson bomber, the Lodestar, and now Lockheed's answer to the challenge of our times, the interceptor pursuit P-38. It has been developed solely for national defense, and Army officials consider it the fastest military plane in the world today. The P-38, a man-made comet. The P-38 is a completely new development in conception and design. The purpose of this deadly single-seater fighter is to prevent any would-be attacker from reaching his objective. Lockheed is building vast quantities for the United States Army, and many of its features are closely guarded military secrets. But it can be revealed that the P-38 will climb a mile in a minute, and its motors are so quiet that it can approach any target almost without warning. And as wings soar higher above America, so are soaring the hopes of free men the world over. For they know that whether it be for commerce or defense, ship for ship, American planes have no equal. And just as Lockheed commercial transports serve the people, so do the Lockheed military planes stand ready to serve should the need arise. The striking power of Hudson bombers, the speed of the P-38, envisioned by Lockheed, engineered by Lockheed, built by Lockheed. Wings of eagles for the protection of our country. Wings of progress for the prosperity of our people, today and tomorrow. And the airplane of that tomorrow, who knows what it will be, for the march of aviation has been so swift. But whatever it is, the world will look to Lockheed leadership then as it looks to Lockheed for leadership today.
In the late 1980s, the management of Lockheed Corporation reached a decision to vacate the huge factory complex at Burbank, where aircraft had been built for over 60 years. The time had come to move the aircraft work to more modern facilities elsewhere. By 1990, people and equipment were gone from many obsolete buildings that had covered more than 300 acres. These included the structures where, in 1928, Alan Lockheed and a small group of employees began making wooden airplanes in buildings once occupied by makers of china and glassware. It was on this site, 4 years later, that the current Lockheed Corporation was born. Lockheed's announcement that most of the buildings would soon be torn down stirred memories among many who had known the company in its early years. One of them was Harvey Kristen, who had joined the company soon after it moved to Burbank from Hollywood. As a teenage student from Pasadena, Kristen took a temporary job at Lockheed in 1928 and stayed on for nearly half a century until his retirement in 1974. Working in many branches of the company, Kristen was an eyewitness to events that took the firm from a fledgling in Burbank to a giant of the aerospace industry.
This is where it all began, our first day at work at Lockheed. To my rear was San Fernando Road and Empire Avenue. To my right, the Mission Glass Company. To the left, the China factory. Behind this venerable brick wall, the China company had become a very important part of the Lockheed complex, utilized for fabrication and subassembly.
When Kristen joined Lockheed Aircraft Company, it had only 80 employees, some working in this building that had belonged to the Empire China Company.
They were building the Vega, a high-wing monoplane made of Sitka spruce, and almost in its entirety. Well, since the fuselage, the empennage, the wing, everything but the landing gear and the power plant were made of Sitka spruce, we used principally highly qualified cabinet makers. These men were extremely proficient in following layout drawings, engineering drawings precisely. They made temporary tooling of wood to make ribs, to form the airfoil of the wing. They had a mold that made the diaphragms, the bulkheads, which, by the way, were made of almost 20 to 30 laminations of Sitka spruce. And I must add that at this point, and this is important, a piece of Sitka spruce, 1/4 by 3/4 by 24 inch long, 8 annular growth rings to the inch, free of all rosin or leaks, pulled 24,000 psi, laminated into a bulkhead. It pulled 120,000 psi, which is the equivalent of some pretty high-grade chromolybdom steel. Didn't know that at the time, but we found out later that spruce airplane. Had the qualities and the strengths of many, many metals, but had the flexibility of a spruce tree.
Leading the small group of airplane builders was a man whose name would become famous in the industry, Alan Lockheed.
Alan and his brothers, Malcolm and Victor, were in on the original group with their chief designer, well-known man, Jack Northrop, who was the outstanding creator of the monocoque fuselage and the type of airplane that the Lockheed Vega and other models turned out to be. A man named Tony Stadelman, who came from Czechoslovakia by way of the Middle West, turned out to be the factory man, the builder, the man who could take all of Northrop's designs and create them into an airplane. These men I just mentioned were the principals of the Lockheed Company that came to Burbank.
Production of the Vega and other wooden aircraft at Burbank was threatened in 1929 when the American economy went into a tailspin.
And the Lockheed Company was struggling to maintain its workforce and its capacity, which was minimal. And Alan Lockheed was approached by a group from Detroit who formed Detroit Aircraft, who had hoped someday to become the General Motors of the Air, and Lockheed was one of their acquisitions, along with Ryan Aircraft, Parks Air College, and Evans Pump Company, etc. But they no more than established themselves as the new owners of Detroit Aircraft, bringing their executives to our company. And along came a very, very, very difficult time known as the Depression, the Great Depression. So Detroit Aircraft found themselves overextended financially, and they went into bankruptcy. And coincident to that, a far-sighted individual who was a Detroit Aircraft executive and general manager of this plant representative named Carl B. Squire, worked with local people through the Title Insurance Trust Company, and were able to put the Lockheed Company into receivership under California law, prohibiting then the company to be sold off piecemeal and disappear as a name, as an asset of the Detroit Aircraft Company. There were only 3 people in the entire company during the Title Insurance Trust Company and California receivership. Carl B. Squire, who stayed here from the Detroit organization as general manager for them, became the head man of representing the receivers. A chap named Ronald King was the bookkeeper, and a fellow named Harv Kristen was the factory man, handling minor repairs, shipping spare parts, providing spare parts, bringing in crews as necessary by Mr. Squire's orders and the customer's agreement to do major repairs. We kept the plant open on an on-call basis, and we paid, by the way, not by checks, but by cash envelopes, by the hour, by the job. In June of 1932, a small group of investors headed by Robert Gross, including Cyril Chapelet, Carl Squire, Mr. Ryan and Larry Ames, and Walter Barney of the Barney Speed Lines, were able to put together $40,000, which seemed to be an appropriate bid at the time for the company. There were others that attempted to consolidate and be bidders, but did not quite make it. Therefore, on the day of the court sale, Mr. Carl Squire, who was going to represent those of us that were at the factory, suggested that I might go down and witness the sale. We took the Lockheed truck. I took the Lockheed truck. We drove down, sat in the rear of the courtroom, very inconspicuously, and observed the following. When Robert Gross presented the $40,000 check to the judge turned to him before closing the sale It said, "Young man, I hope you know what you're doing." And Mr. Robert Gross said, "Yes, sir," most enthusiastically. And with that, the judge hit the gavel on the desk, and sold was his statement. And that concluded the sale out of receivership, but the beginning of our wonderful company that we have today. You know, there was an era in the aviation world when it took a Lockheed to beat a Lockheed. And when better airplanes were built, we said, Lockheed will build them. And that's when the Vega brought the good name Lockheed into the limelight as the most reliable, best performing, highest cruising speed, best fuel consumption airplane flying in its day. Famous pilots, Wiley Post, who flew around the world on 2 occasions, once with a navigator and once alone, and then broke the record for high altitude performance with a flying suit of its day, the forerunner of today's astronaut suits, by making a little red Vega that normally cruised at 150 miles an hour, cruise at 350 from our Southern California to the East Coast. Other than Wiley, there were famous pilots such as Roscoe Turner, who flew for Gilmore Oil Company. He was a flamboyant type of a pilot, but he brought great credit to our airplanes, both the Vega and the Air Express, which became the Earl Gilmore Oil Company airplane, where he, as his mascot, carried the lion Gilmore. Other pilots such as Sir Charles Kingsford Smith, who flew the Pacific in a Lockheed L Terror. And then there was the Magyar brothers, who flew the Justice for Hungary from New York to Budapest, bringing to the attention of the world the freedom for Hungary. Well, Jimmy Doolittle came to us as a bit of a hero because he had made the first flying landing in Dayton, Ohio under a hood. Had never been done before. Complete landing without sight of the terra firma. When Jimmy Doolittle acquired his Lockheed Orion, a derivative of the old original Vega design, he was the research pilot for the Shell Oil Company. By 1934, the company had made the management decision to proceed with this new Electra Model 10A. And it was built assembled primarily in the hangars that were left here by the old original Lockheed Detroit Aircraft Company. Final assembly, if you please, outside of the hangars because the hangars are not big enough to take on the wings of the airplane and the assembly. From there, they proceeded to our own little flight line along this railroad strip, not yet anything but a dirt runway. And from there, the initial Electra flew and was tested and accepted by our then chief test pilot, Marshall Heedle, and a pilot on loan from the Boeing Company. The reports on this new twin-engine, all-metal version of the Lockheed airplane began to come back from Michigan, recommending the abandonment of the single fin and rudder and the adding of the double tail, the twin fins and rudders, for directional stability, for single-engine outperformance. And that was accepted on the spot. And as a result of that decision, that became the hallmark of the Model 10 Electra, this double tail. And it was recommended by none other than Clarence L. Johnson, who very shortly became the chief aerodynamics of our present company. During the 1930s, some very interesting and famous pilots came by to evaluate our Electra because of its very, very high performance characteristics, and especially its single-engine performance and its long range. Amelia Earhart was another one of those famous and wonderful persons that we got so well acquainted with because when Amelia came to acquire her first little red Vega, as she called it, she put on a pair of Lockheed coveralls and went out in the shop and worked next to the woodworkers and the cabinet makers and then the final assembly and went out on the flight line as part of the crew and was a most gracious lady and a most appreciative lady because she knew when she flew her airplane, almost every nut and bolt of any importance as it was assembled. Her confidence factor was improved immensely by the fact that she was a part of the building of her little red Vega. And naturally, we were so proud of her because she flew the Atlantic alone and was quickly named Lady Lindy. When she flew the Atlantic, she, of course, landed in Londonderry, Ireland. And the people, of course, were most gracious and most appreciative of her wonderful accomplishment. Later on, in years to come, we had another great experience with Amelia when she came out to personally become involved, just as she did on the Vega with her Model 10E Electra. That it was very specially built for her because she was going to carry approximately 1,100 gallons of fuel. She was going to have special navigation equipment. And in the process of building her airplane, once again, she put on coveralls and became especially involved in what we called our QEC, our power plant installations. In fact, I can recall her help plumbing and the engine installation because she wanted to know firsthand how and where the fuel, the electrical power, everything came from in the power of the airplane, knowing full well that with two engines, she'd need them both with the heavy load takeoff that she was about to make on the round-the-world flight. In other words, once again, Amelia became part of our crew, part of us, in the process of building an airplane. Another demonstration of a great pioneer and a wonderful lady. Then there was Charles Lindbergh and his wife Anne, who frequented our place daily almost during the process of the building of their cirrus. We built it, of course, as a fixed-gear land plane. But knowing in the final analysis that he was going to do a route survey of the Pacific for Pan American, but that cirrus that he and Morrill Lindbergh acquired was very special because we put a canopy on, we put things on to protect them from the elements because Anne became his navigator and his radio operator. Just think of it. Here's a lady that just never had had an experience like that until she married this wonderful pilot, this wonderful fellow, Slim Lindbergh. They eventually, of course, put floats on the airplane. And testing that airplane, which we'd never put floats on before, was quite a unique experience. Again, the center of gravity, fuel loading, and the takeoff characteristics of a seaplane, so different than a land plane, caused us to go through some very interesting, we called them high taxis. And of course, to get a float up on the step, you almost have to have a turbulent sea. A smooth sea gets you nowhere. Lindbergh knew that. And they used to go ahead of him when he tested with a high-speed boat to create the turbulence in the waves and the water in the wake of the boat to help him get the vacuum broken under the steps of his floats. What an experience it was for us because we had never built a low-wing cirrus seaplane before. Yet another wonderful experience was to have this great pioneer, most enthusiastic aviation man named Howard Hughes come to our plant with a little Boeing P-12 and ask Kelly Johnson and our engineers and Mr. Gross if we could modify it and turn it into a high-speed racer. It turned out that it was my good fortune to be in charge of that project. And we had a no-holds-bar latitude. We could get anything anywhere we wanted at any time. We stripped the fabric down to the bare tubular skeleton. And with a little skill and special engineering, we were able to make it into a monocoque-type shaped fuselage with sheet metal, streamline it, put streamlined gear, landing gear on, add a terrifically heavy-duty, high-powered power plant, compensate for the center of gravity for Howard. We accomplished that in weeks, not months. And following that, we had the great experience of Howard selecting the Super Electra, we call it the Model 14, to fly around the world. And of course, that took special handling with regard to fuel consumption, fuel capacity, navigation gear, navigation equipment. And in 14 days plus, I believe it was, he made the round-the-world flight and very successfully demonstrated that transport equipment, commercial transport equipment, was able to make some of these extended hops under controlled conditions.
In the 1930s, before Lockheed had any facilities at the nearby commercial airport in Burbank, the company did all of its flying from a dirt runway between Empire Avenue and the railroad tracks.
This is the site of the original 2,000-foot dirt runway, gopher holes and all. It's from this very runway that the famous Winnie Mae of Wally Post, Amelia Earhart's Little Red Vega, Sir Charles Kingsford Smith's Altair, Lindbergh's Cirrus, all of them flew from this very runway.
In the late 30s, war broke out in Europe. The British had an urgent need for new aircraft. Lockheed offered to build a new bomber.
During that period, we had expanded the design of the Electra into what we called the Model 14, which was an enlarged semi-mid-wing version of a twin-engine, two-tail airplane. And at that particular time, the British were interested in getting support in the form of a patrol airplane to protect the coast of all of the British Isles. They came to the United States and reviewed the designs of our aircraft and others, competitors. They chose the Model 14, which we, in a 24-hour period under Kelly Johnson's supervision, converted into a mock-up of a Hudson bomber. And this is a very, very important area of the original Lockheed as we know it today. This is where Robert Gross's executives presided in their offices we knew as Mahogany Row. Also, this very spot, and through a switchboard, right up in that corner, came the word from London, England, from Cortlandt Gross to Robert and his team that the Hudson bomber contract, up to that time the largest contract ever given to anyone in these United States, was consummated. When we received that order, immediately we had a procurement program established that was second to none, with the organizations such as the Aluminum Company of America and the engine manufacturers, because 200 Hudson bombers in one initial order never had come to any company in that quantity before, on a schedule that was so uniquely developed to meet British requirements. And next requirement became, where are we going to build all these airplanes? So the company could only expand in one direction, because Burbank was on the east, and that was it. So westward we came. We closed off a street called Lincoln Avenue and moved all the way up to Buena Vista, which is a offshoot of San Fernando Road and Turkey Crossing, where the little plant first started. As production accelerated and we were beginning to accumulate airplanes in our test area, and by the way, our test strip was the old dirt runway at B1. We did not have a paved runway, no lights, no traffic control. We were the traffic control by way of the pilot house, as we called it, right at the edge of that little runway at Burbank. And that's where the Hudson started its first testing, its first flying. You know, during the midpoint, or as we became quite well established on our Hudson line, along come a design competition that Kelly Johnson entered for Lockheed. Turned out that it became Lightning, the twin-tailed P-38. So what we did is we divided the assembly line into a Hudson line and a P-38 line, and started the P-38 line down through the same general overall assembly building, paralleling the Hudson bomber. The rate of the P-38 was slow and accelerating initially, but we got it up to where many P-38s a day came off that line, even faster production schedule than the Hudson. The P-38 program probably accelerated faster than any line in the area. We got to a point where we were able to roll a P-38 in an hour, but we had control over the condition of those airplanes to the extent that you could pick any airplane and decide what the status was and bring it up to flight status immediately upon receipt of whatever the requirements were that were missing in the assembly line. We had absolute control. The result was very few run-up failures or test flight failures. We had quality control by pride of workmanship and by a group of people who knew by experience on the Hudson line how to handle the accelerated program on the P-38. So the Hudson program became a very, very invaluable or valuable program for developing our skills to take on a dual assembly line at the time. The Hudson and the P-38 required no end of additional skills in piloting our airplanes, and we brought in some very, very famous people who maybe at the time were not, but became so important to the Air Force and to ourselves. To name but a few, Milo Burcham, who had flown with a group in a Boeing P-12 at air shows and had the skills that came with aerobatics and acrobatics and knew how to recover an airplane from test flighting conditions that you deliberately put the airplane through. So Milo became a very key figure. When Tony LeBeer came on board, little did we know that he was to bring that very unique skill. To Tony, the impossible was just a little more difficult. Tony was able to do things with the P-38, as was his partner, Fish Salmon, who became famous also. They literally flew test flights, monitoring each other, confirming each other's results, which was a rather unique condition. Tony would take a P-38 up and ring it out, go into a flat spin, do the impossible recoveries to satisfy Kelly, to confirm that not just one man could do it. Fish Salmon would go up and repeat the performance. All the while, Milo, who was chief pilot at the time, was biting his fingernails, hoping these two fellows didn't tangle, because sometimes they'd go up and literally do what we used to call combat-type maneuvers with each other. Right about the time that the P-38 and the Hudson were going full swing, there was a need for second sources of some very prominent and very important airplanes, and one of them was the B-17. So all of a sudden there became a subsidiary that had already started in the old China factory at what we call the old Lockheed Company as a design group with Max Short and a few important people that came from the Stearman Company. This fully owned subsidiary was known as the Vega Company, very proudly, because the Vega, in its early days, as you know, made the name Lockheed quite famous. So as the Vega Company came into being as the second source for the B-17 program designed by the Boeing company, it became the number one second source, the other source being Tulsa, Oklahoma, run by the Douglas Company. The Vega Company built the facility around the assembly lines as they developed and the fabrication shops developed, expanded as the airplanes were being built and assembled, literally built the buildings over the workforce. This excellent facility of its day, built on the southeast corner of the airport, was to become the home of the Vega Company, a wholly owned subsidiary of Lockheed. One of the unique things about the Vega Company was when the Boeing Company had a challenge that would come from the Air Force to modify a B-17, the request would go out to the two subsidiaries. The first chin turret to protect the nose of the gunner and the nose of the airplane and the crew was a Vega installation. And I remember well going to the Long Beach staging area where we took our P-38s and Hudsons that were flown into the Pacific Theater. The Hudsons to Australia, the P-38s into the General Kenny's work task force. That when a B-17 showed up at Long Beach with a chin turret on, you watched the ferry command. They'd come out and walk up and down that line. And when they saw a chin turret on the airplane, that was their baby, because not a one had to be ditched in the drink. The Vega B-17 line, as we knew it, was built in the facilities adjacent to Hollywood Way, and literally in a facility that wrapped itself around the then Lockheed Air Terminal. And they successfully produced well over 2,000 B-17s on schedule to latest Air Force requirements with a quality standard that made them second to none. You know, about that time, Pearl Harbor, the scare of the submarine off of Galita, there was a scare that came across the entire West Coast. Shipbuilders, airplane builders, anybody that was vital to the defense program had to have the ultimate of protection. And somebody came up with the idea of camouflaging our plants. And this was quite an experience, because once again, all the trusses and all the cables and all the support structure had to be built over our heads as we were building airplanes. And the part that was so darn messy was the fact that they used chicken wire, as we called it, to stretch over these buttresses and cables and so forth over our plant. And then what did they do but blow feathers with an adhesive, waterproof adhesive, onto these wires. So we were picking chicken feathers out of our airplanes, out of our hair, all at the time we were building airplanes. But believe it or not, when we found out through aerial shots what our plant looked like from the air, we suddenly discovered we were a little community of houses and business buildings that somehow or other, the giveaway only that we detected was the fact that a railroad track ended and began in the middle of this little community that was called camouflage. Right in the middle of this intense production program, our great Kelly came up with another dream. Because suddenly there'd become available in England an engine designed by a Mr. Whittle. It was called the Whittle turbine. And while that was going on, Kelly had already designed on paper how he was going to apply that little engine and that thrust to an airplane. That airplane became known as Loughead. It was built in tents. It was built in little buildings that suddenly became vacated and available, and then became secured and fenced off. And suddenly out of that little complex came drawings. We who were building the production airplanes suddenly became aware of a drawing that would come out for a forging and a part that had a peculiar name, like McCormick Deering Tractor, had no relationship to an airplane, to keep the design secretive. And when that went out to a forging company or whoever it was that made that component, they were put in a position of not needing to know. And that was the key. Unless you had a need to know, you didn't ask questions, you didn't become involved. So as Kelly built Loughead in a record 143 days, towed it up to then Muroc Dry Lake, now Edwards Air Force Base. And again, here comes that wonderful guy, Milo Burcham, who was elected to make the first flight in Loughead. Loughead flew, was very successful. The thing that Milo said, gosh, it maneuvers well, it's fast, and it gives you a feeling of confidence.
The flight of the XP-80 in 1944 launched Lockheed into the jet age. This design would evolve into America's first production jet fighter, the Air Force Shooting Star. While the first flights were being made, a new building was under construction on Empire Avenue, where the Skunk Works team would begin production of P-80s.
This is the famous cotton shed, built and patterned after the cotton bale storage places of the South. It was where the YP-80s were built, which were the forerunner of the production version, the P-80 Shooting Star. In the middle of the YP-80 project came a very special assignment. Secretively, we were to put slipper tanks out on the wingtips.
The wingtip fuel tanks gave the P-80 enough range for combat missions. The Burbank plant built over 1,000 P-80s. In the 1950s, they served in the Korean War and elsewhere around the world. Just before World War II, Lockheed had designed a large new transport. It was given a name that would become widely known.
The name Constellation became a famous name in our company, and we always named our airplanes after stars or constellations of stars. And the Cirrus was a star, the Vega was a star, the Altair was a star, and along comes the need for a bright and shiny new airplane that had the benefit of all those that had gone before, and it became a Constellation. And its nickname was the Connie. It was one of those unique experiences where a customer, naturally, in those days had to be found for their first group. Well, the customer turned out to be TWA, owned by none other than, at that time, our friend Howard Hughes. So as Kelly Johnson and his design staff and Robert and Cortland Gross and Howard Hughes would meet, they would draw and submit ideas of what the configuration should look like. One interesting experience, and this is a factual experience. The first design that came up was a typical, very straightforward cigar-shaped fuselage. And it had a multiple tail, but it didn't look like what the Connie turned out to be. Mr. Gross looked at that airplane, as did Howard and the rest, and it was a very efficient-looking, straightforward design. Every section of that fuselage was identical. It was ideal for production. But Mr. Gross says that airplane doesn't look like it really wants to fly freely. Why don't we do this? He walked up to the blackboard, and he drew a couple lines that looked like a side view of a dolphin. And Kelly looked at that, and Howard looked at that, and they said, well, if we do that, technically the fuselage becomes an airfoil because your shape is like the wing rib of an airplane wing. So all of a sudden, right then and there, In spite of the need for standardized production, we had a multiple shape design that, of course, made new bulkheads at every station and made it a little complex initially. But oh, how it contributed to the reputation of that airplane.
The first Constellations came off the Burbank assembly lines during World War II and served as military transports. At war's end, commercial airlines would begin ordering Constellations. Eventually, they would be in passenger service around the world.
To see it in the air was to see the most graceful airplane. And that Connie became the flagship of Pan American, Eastern Airlines, Chicago and Southern that became Delta, and many airlines in the European theater. Even Qantas Airlines down in the South Pacific, they put drop tanks, tip tanks on the wing, extended the range and made it look almost like a version of a military airplane, but it still had the grace of a Connie, and that airplane was, in a commercial sense, the airplane that took us into the next and the next and the next generation of Lockheed airplanes.
The military Constellation assembly line was one of many production lines that operated simultaneously at Burbank during World War II. Employment grew by the tens of thousands to meet wartime schedules.
The employment grew so fast, keeping head count was a near impossibility for us in the factory area. In fact, it wasn't our responsibility. We made the demand, the requirement. The personnel department brought them in and trained them. We certified them as being ready to go. We had a last word to say he's ready or send him back for a little more, give him a little more help. But in that process, all of a sudden, including our outlying plants as far away as Bakersfield, Beverly Hills, believe it or not, the old Ford motor plant called B2, the old Willys Overland plant in Maywood, where we made our drop tanks for our P-38s. All of those airplanes and all of those called for the maximum effort on personnel and training. At that point, we passed well over the 90,000 mark. In fact, some of our people will insist that we did reach the 100,000 mark. Conservatively speaking, I would say 90,000 plus. From a little company that, remember, started in 1928 with 80 people.
Many women joined the wartime workforce.
Yes, oh, the women came into Lockheed. They reached a peak of almost 40% of our production workforce. They particularly adapted well to precision work. Their fingers were more nimble. We were all thumbs. They could put an instrument panel together. They could assemble wiring bundles to install as a unit into the airplanes. They could assemble hydraulic units very precisely. They adapted so beautifully. And we brought that term out at the Vega company called Rosie the Riveter. But believe it or not, Rosie the Riveter was a symbol, but the riveting was one of many, many skills that they brought to our company.
During the war, the company's Burbank facilities had expanded to cover several hundred acres. Factory buildings spread for half a mile east and west of the old China Company quarters at Empire Avenue and San Fernando Road. A mile to the west, another factory complex had been created for B-17 and Constellation production. By 1945, the Burbank factories had built almost 19,000 combat aircraft for America and her allies. When the war was over, Lockheed continued production of Constellations in commercial airline as well as military versions. The company and its Vega subsidiary also began designing new aircraft, including one for the Navy's anti-submarine patrol missions. It was named the Neptune.
They wanted it to be compact, not cumbersome, small by comparison. So they come up with the idea that it would be a two-engine airplane with a tremendous fuel capacity to stay on station and yet have the ability to carry the payload that was required. And it had to have some unique features never before installed. For instance, it required a magnetometer that heretofore had been used in the oil industry to find and locate oil fields, which was a device that was attached to the airplane. It looked like a stinger. And so the P-2V Neptune was the second breath, you might say, of the beginning of the very successful career of the Vega Airplane Company and its contribution to the services. And another version, Operation High Jump, South Pole Expedition. Suddenly, we got the request to develop a ski airplane. Well, it would come out that it wasn't just one. It was a sequence of ski airplanes, backup airplanes, where the Navy was going to go to the South Pole and do some exploratory work. Another very important contribution that P-2V was made to the Navy and to our services and to our country was the fact that it demonstrated that it had the ability to stay airborne for hours beyond any aircraft up to that point. To demonstrate that, a commander took an airplane and designated the Truculent Turtle. What a name for an airplane that performed like the P-2V. He flew that airplane nonstop from Australia to Columbus, Ohio. And incidentally, when he landed, he played it safe. He had enough fuel on board. He could have gone to the Navy base in Washington, D.C.
During 16 years, starting in 1946, the Burbank plant built more than 1,000 Neptunes in many versions. The P-2 also was built by the Japanese under license from Lockheed. The factory buildings expanded in the 1940s to produce a variety of aircraft types, including one that would become the biggest airplane ever built in Burbank. Its assembly would require Lockheed's largest building in Burbank.
In the mid-1940s, Lockheed was fortunate enough to be contacted by the Navy to develop a heretofore never designed or built aircraft known as the Constitution. It required a very special hangar. We called it the Constitution hangar because it had to have a clearance for that fin on that Constitution of 6 stories. The cockpit, in fact, was 3 stories above the ground. This facility hereafter was known as the Constitution hangar.
Designed to take off at a maximum weight of 92 tons, the Constitution needed turbine engines. Because turbines were not yet available, the 2 prototypes began their test flying with piston engines of 3,000 horsepower each. The mission was to transport Navy personnel and their equipment, as well as a senior officer in an airborne command post.
We took the initial first number, serial number 1, to Patuxent River. And to the amazement of the Navy test pilots in the program down at Pax River, this airplane did things that no other airplane had ever done. And why? Because for the lack of the turbine engines, we installed JATO bottles integral to the wing. And we could take that airplane off the ground with the equivalent of 5 engines in power. Each of those JATO bottles developed 1,000 pounds of thrust for 14 seconds. And when you put 16 turbine valves, 8 on each side, 1,000 pounds each, suddenly you had 16,000 pounds of JATO thrust.
Lack of power kept the Constitution from full production, but the prototypes were forerunners of huge jet transports that would fly 20 years later. By the mid-1950s, turboprop engines were available. Lockheed began producing a new commercial airliner, the L-188 Electra, using Allison T-56 engines.
It was a unique engine because it was a turboprop with a gearbox, but it had 2 speeds. It had a ground idle and it had a cruise. So our L-188, known as the Electra, and our C-130, known as Hercules, the Hercules being developed in the Skunk Works, almost parallel to the Electra, being developed in our production line. Of course, also demonstrated through our flight engineering group, which was closely tied to our Skunk Works operation because we were using the same power plants. We come up with this unique development where we could give to the airline commercially an airplane that could get in and out of facilities that no other, even reciprocating engine, in some instances, could handle, because of its unique ability to use maximum power with a constant speed engine. So the L-188 became a forerunner, of course, of the pure jet airplane, and airlines like American and Eastern flew that airplane and got maximum performance out of the airplane.
The arrival of the pure jets brought an end to Electra production after only 170 sales. But the basic design would soon lead to a new naval patrol aircraft that would remain in production for decades.
As the transition from turboprop to pure jets come along, and the Electra line had served its purpose during that transition period, we had an airframe, we had a hull, so to speak, that had many potentials. And we had a power plant that had obvious growth, and it became the Navy version of the L-188, which is known as the P-3 Orion, or the P-3 ASW aircraft.
Lockheed built more than 500 P-3s at Burbank before production was moved to other facilities. The Orion became the principal maritime patrol aircraft of a dozen nations. At Burbank, new ideas led to additional designs that were built at other Lockheed facilities. The Skunk Works P-80 fighter evolved into a 2-seat trainer, the T-33. Over 5,000 were built at Palmdale for air forces worldwide. In the 1950s, a need for a long-range, very high-altitude reconnaissance aircraft inspired Kelly Johnson and his team to design the U-2.
There was an airplane that had to be able to develop an ability to go out of the range of then-known missiles, altitude-wise, and have a range, fuel consumption-wise, that was with a very slim glider type, or soaring glider type wing, with a bicycle landing gear, a couple outriggers, a very reliable power plant.
With Johnson on the U-2 and later on other key programs was Ben Rich, who was to become head of the Skunk Works when Johnson retired. America's first Mach 2 fighter also emerged from the Skunk Works in the 50s. Over 700 starfighters were built at Palmdale, and 2,000 more were produced by foreign manufacturers. In Italy, production continued through the 1970s.
I think it'll be a long, long time before we have an airplane that has higher performance than the SR-71, because the need for it is not there in terms of the fact that we can have satellites circling the Earth in 90 minutes, and we do not have to go any faster than what we go with this one right here, and it'd be very, very expensive to go Mach 4 or faster. So we may be seeing here the highest speed military airplane that there will be around for a long time.
In 1969, Lockheed received a Navy contract to develop a new anti-submarine patrol aircraft that would operate from carriers. Production soon began at Burbank.
Coincident to the production of the P-3 and as a parallel and a new development came an onboard carrier type, a two-engined anti-submarine warfare airplane that had multiple missions even beyond the basic ASW as a tanker, as a support aircraft for the PS-3 fleet, which accompanied the carriers. That airplane is in operation today and with modifications has been updated to concurrent requirements of the Navy and will be known as the first ASW type Lockheed built carrier airplane. In the 1970s, we came into the wide-bodied jet field with a high-capacity L-1011 TriStar, airplane that was so far ahead of its competition design-wise and capability-wise that it became another hallmark of Lockheed achievement. It was fabricated, sub-assembled in Burbank. The assembly line and the delivery operation was at Palmdale in a new facility built primarily for L-1011 production. The airplane, even today, is in use in various parts of the world, and you hear of it having new duties to perform by new operators, new challenges, and it'll be around for a long time as a standard.
The last airplane Lockheed built at the Burbank plant was completed in 1990. It was an F-117A stealth fighter, produced in secrecy like many of its predecessors by the Skunk Works.
You know, this stealth fighter, as it turns out, will be the very last complete, total design, fabricated, built, assembled airplane on our Burbank property. It will have, for its lifetime, the signature of Ben Rich, endorsed by Kelly Johnson. And by a strange coincidence, I must add that the wingspan of that little F-117A stealth fighter is exactly the same wingspan of the original Lockheed Vega, 42 feet. Just to hearken back to the genesis of Lockheed, the incubator days of the old plywood Vega. And I'm sure Ben would acknowledge that the chain of development and the heritage of Lockheed has inspired him, as it has all of us, to continue to come forward with the best that there is that Lockheed has to offer.
Within months after production was completed, Air Force stealth fighters were flying combat missions in the Middle East, writing another chapter in Lockheed's development of advanced airborne technology. Among the facilities vacated in 1991 was one built in 1941 that was used for decades as headquarters.
This building, just across the street from the airport, served as the headquarters, the home, and the heart of Lockheed. It was first or initially occupied by the Vega Company, followed by the Lockheed California Company, then the corporate headquarters, and finally is the home of the Lockheed Aeronautical Systems Company. This building was the headquarters of our pioneering chairman of the board, Robert Ellsworth Gross. Robert Gross was a great visionary. He saw the potential in the future of our company. He was followed then by his brother Cortland, who Robert Gross always gave credit to for the man that got the job done. Cortland then was followed by an outstanding young man who came to us from outside the company. His name was Daniel J. Houghton. Dan brought a broad experience in leadership and in his strengths that came naturally to Dan of bringing people together to execute a common project or objective. Then he was followed by a man from outside the industry, Robert Hack. He carried us through a very difficult transition period. He saw the strengths in our company, and he pointed out to us those areas where we could be even stronger. Roy Anderson came to us with a financial background out of Stanford University. Roy brought to us his abilities to select and develop people and put a team together. Roy then was followed by the last chairman of the board to occupy this now famous building. His name is Larry Kitchen, a fighting Marine. Larry didn't know how to use or spell the word quit. Larry was a man who got the job done and who put the team together and developed a common objective.
Corporate headquarters moved from Burbank to a new location in 1986, and soon decisions would be made to vacate the once bustling manufacturing buildings as well.
Change, it goes beyond our changing of our product. It goes beyond the changing of our facility requirements to keep up with technology. Therefore, when we restructure our company to meet the changing times and the ambient environment or conditions we work under, both contractually, both market-wise, both in our product lines, we must be sure that to survive as a viable company ready to take on new and yet unknown responsibilities require us to accept change as gracefully as we can, knowing that in some instances it could be a hardship. On other instances, and these are the ones I like to think about, they create new opportunities. I'm reminded of one statement that goes with just what's happening today in our restructuring of our company and our facilities. It's Robert Gross's statement. He said early on, when you work in the field of the air, you instinctively look up, not down. You instinctively look ahead, not back. You look ahead where the horizons are absolutely unlimited. And looking ahead is what we must do today, and accept change, and accept the need to grow and to take advantage of the changing times and the opportunities they make available to us.
Harvey Kristen returned to the old plant site for a last look at the vacant buildings where Robert Gross had his original office at Lockheed.
These 50 years of association with our dear Lockheed has been an adventure in friendships and relationships of the greats of our company and the greats who flew our airplanes. This then teenager will cherish those memories forever.